We're in Spokane today, and we're reviewing the various types of toolbars that we utilize from the Case 940 to the new TCA and AA bars, as well as the Exactrix AAA bar. We actually have four favorite bar choices that we now use. A lot of it is designed around the need to binary band or to rearrange openers in a rank. And so we run double bars. You'll see a few single bars. There'll be a few single bars that you'll see out there, but they basically aren't strong enough or durable enough to continue with a high-speed 12 mile per hour application. So we've reset the criteria for how toolbars operate and how much more open they can be. And so since we have 12-inch spacing all the way up to 40-inch spacing, we need to keep the toolbar open. So I'll give you a quick overview here of what we have in AAA design. And at the screen today, you're going to find some features that you may not have seen before. And these are designed for up to 680 horsepower at 90 feet. And we're looking primarily here at the 3-point mount arrangement, 2-point, mount arrangement, using a steering axle group in the back rather than lift assist wheels. The steering axles can also be GPS steered automatically, and they can pull with a ball and socket, or they can pull with a winch type system. So some of the larger machines we build require ball and socket and reach steering to the track cart. The center frame is built quite heavy. It's 12 by 8, and it's half-inch wall. And it's held together at both sides with these stringers that are 1.5-inch material. And the stringers are the push points for the hydraulic cylinders. These lifting cylinders are either 6-inch or 7-inch. And they're about a 36-inch stroke. And so it allows us to design sections pin to pin of 17.5 feet, you see here. About 210 inches is the width of the center section, which leaves it very open so we can see what's going on behind us. And of course, they 2-point mount off of these locations here. So 12 by 8 toolbar. The reason it's 12 inches in overall length of center section is we're putting about 680 horsepower through that center section with a steering axle group in back. And so this axle group can actually tell the machine where to go. So a little bit different. Another feature that I think is outstanding, and we've utilized it several times in boom and track design, is a steering flexing ball. And there's two 4-inch balls installed in these sections. And you can see the balls. They're easily removable, and it allows the toolbar to actually twist a little bit and flex and yet fold with minimum pressures in folding, which means you can apply down pressure without any type of binding when you use spherical balls in the boom transition points. So you notice here, this is the center section. It's 12/8. And we're going to go down here and we're going to go take a look at the next section. And it's a little different. It's a 10-inch section. So it transitions from 12 by 8 to 10 by 8 in the second section, or the midsection if you're dealing in a 5-section machine design. So let's roll out a little bit. And there is the second section. And then there is the outside section, which is if you're going to go up to 60 or beyond 45 feet, 60 and 70 foot widths. Then we have an 8 by 8 frame design And there, of course, is the ball arrangement that we were talking about. And the balls just fit into their sockets. So they're easy to break down, and for transport purposes, we simply have these flange caps that are removed and allow us to get in there and remove the section. The sections are also tied together with 1.5-inch stringers, and we bolt those stringers right to the frame rather than welding them. And the reason is because of ball and socket. We can have a little bit of flex, a little bit of give and go in the frame, and that's absorbed in the ball and sockets without having to bind or throw the mechanism into a plane that it cannot bend. And this is one of the problems with shafts, pin and shaft designs, is that they are very, very rigid. So we get a lot of flexing in the design that allows us to go up to 680 horsepower. Back it out a little bit. You'll notice that the openers can be mounted in several locations across the width of the toolbar without interference. And if we do run into an interference problem, we can relocate a stringer, as an example. We can also bolt in more stringers if we need more structural support. Sometimes we'll go to 12-inch band centers. We may go 15, we may go 20, 25, 24. And we may do progressive banding, so it's very important to have these sectional designs that allow openers to be mounted in 2 ranks. Another reason why we have 2 rank designs is that the progressive functionality, a hard spot in the field or a track, allows the first opener to penetrate, and then the force is moved to the back gang. That back gang will handle the same difficulties very well, so it moves that down pressure force back and forth, and of course we have springs that absorb the differences. The machines are normally running on a 120-inch gauge, but that's adjustable. We can change that. We steer the rear steer axle. In most cases, we just let it caster. In other words, we can tilt it a small amount and create a caster, which makes it into a self-steering unit. And the machine has the ability to fold up to 5 times. But we're going to look at a simple 3-section. It's about 265 inches in transport, about 22.5 feet. The pin to pin is 17.5. And the toolbar has an elevational difference of from 40 inches at level all the way up to about 65 inches. So it has 25 inches of upward movement that comes from the parallelograms that lift these steering axle groups. I'm going to go look over here. And this is the parallelogram that allows the steer axle to be adjusted upward or downward from the tractor cab. And we change the caster at this upper parallelogram so we can tilt the steering axle slightly forward and create a self-steering effect. So it has an adjustable caster. Side view of the frame, these are the 1.5-inch stringers that go back, and this is of course the back bar. This is the toolbar spacing itself, allows for 2 opener groups to be mounted. Sometimes we like to put openers in line. It's called progressive deep banding. This would be primarily for dryland cotton or modification of field lands that may be severely compacted. Irrigated production would require maybe a pass at 10-inch depth, the bands, in order to fracture surface compaction. So we have a braking opener up front and a striking opener in back, a little bit bigger diameter on the blade. And this allows us to penetrate to 10-inch depths and place nutrients in a vermiculated band, not all at the bottom. It progresses downward from the injection point to the bottom of the slot. Another way to get a little more yield punch out of some difficult soils or soils that need to be manipulated a little bit differently. It's called progressive deep banding. That kind of sums it up. I might point out also that today we've looked at machines in 45 to 70 foot in width. We also build steering tandems and track in custom all the way up to 90 feet, which is a pretty good machine width. And we have dedicated bands to each corn row at 90 feet. And of course, using this new AAA 680 horsepower design allows you to pull big, gigantic track carts. And these are the AAA machines in 75 to 90 feet. We'll have this information available off the net, and if you would like a little more detailed explanation, there'll be some more training videos available on AAA toolbars. Don't forget, we build AA and A series toolbars also, which are used at 280 horsepower to 380 horsepower. AAA breaks into this arena at about 520 and moves up to 680 horsepower all the way to 90 feet. A, AA, and AAA toolbars just need more structure as there's more width, more power, more productivity. So every farming operation has a different need, a different timeline, a different need in durability of the machine. And sometimes we run into some applications where all of a sudden the guy's gone to 25,000 acres in 1 year and the machine's not heavy enough. So that's why we go with CUE openers and AAA designs, is to get more structure into the machine so it has a reliable life of 100 to 200,000 acres of useful life in the machine. That's why we use cat dual cone seals down in the hubs and big Timken bearings. Timken's one of our best suppliers. Been with us for a long time. And we use swiveling openers to break down the bands to where they can go really deep without disturbing the ground. So the secret is no-till, cover cropping, winter wheat, corn on corn, cropping systems that build organic matter, and of course cover cropping for soybeans. And that's where we come in now with the Fumigate Mustard program in the cover cropping mode. That pretty much covers it today. Hope you enjoyed the presentation.